Hello and welcome back. Today we'll be looking at React rendering, and so we're going to be looking at what causes React to re-render, like your React app, and then also how we can make this more efficient. And so the simple answer to this is essentially anytime anything changes. So if that's props, if that's state, if that's functions, anytime any of those changes, that is when React will re-render the UI. Today we're going to look at how we can make that more efficient so that then our apps perform better. To do that, we're going to need to install React DevTools. Just go to this website here. I'll have that linked in the description, and then you just install the extension, and then when you go to inspect, you should have the profiler here and also this component section, but for today we'll just be using the profiler. And if we go back to our code, we'll see here we've just got a basic app where we've got a count component, which simply just has a p tag with count and the cubed count, and then we have the same thing over here, two variables for that. And so far all that it does is increment the count variable. The first step will be to actually look at how this works in terms of re-rendering the UI. So if we go back here and we start profiling now, once I press the increment count button, we see now that it's updated here, and we stop our profiler and we can see that it re-rendered once, and we said what caused this update, so app. So because we clicked the increment count button, which is in app, that caused the re-render, and we can see here exactly what time it re-rendered and how long it took to re-render. This cube count doesn't go up, and that's because it's not actually being changed anywhere. Every time the count variable changes, we want to update cubed without having to manually do that. So what we can do now is introduce a use effect, which will essentially carry out the calculation as soon as the count is changed. This is our use effects function, and the way it works is that every time the dependencies, so count, changes, it's going to run this function, and all this function does right now is just figure out the cubed number of counts. But we could, for example, in an application, every time a search query is changed, then we'll automatically run a fetch to a server in order to get some data. When we come to our browser, we'll see now, if we clear that, we start again, and you can see now we have all of our renders here, and it shows us that it has been updated because we have incremented the count. One thing to note about use effect is that this array is the array of our dependencies, and so if we change that, for example, we can have no dependencies, and that means this function will only be run when the app is first rendered. Since our dependency is count, that means it's only gonna run when count is changed. However, if we were to, for example, accidentally put cubed in there, it means every time cubed is changed, which is within the function, it will be run. So we get an infinite cycle, and just to demonstrate this, we'll have an alert that shows us that cubed has been run. So cubed run. We come back here. Okay, see, we've just entered an infinite cycle, and so it's important that you make sure you've got the right dependencies in there, or else you're going to end up with an infinite cycle like that. In React, we can make use of a concept known as memoization, which is essentially where we can cache values, so that may be data, or it can be functions, or even components in between renders, and so that way we prevent lots of re-renders. To show this, we're actually going to add another component to our app. First, we will add in another value, which is cubed2, and so essentially this is just going to be another variable for storing the cubed value, but this is just going to be our copy value of it. The next step will be to replace our use effects function and add a new function, which is reset, and so reset just sets the cubed2 value, which is our copy value, back to 0, and we've just updated the use effect to also set cubed2 to the cubed value. We're then going to add a new component to our app, and that is count component memo, and so this is just going to be a memoized version of our count component, and we can delete this part. And we've also got a new button here, reset, which resets the value of count cubed2. So now to create that new component, which is count component memo, and we create it just like the previous one. However, you see we've wrapped it in this memo function, and we can just import that from React. And we've also got to define our prop types, so we can copy the prop types for count component. And you see now that we've got a memoized function. So we come back to app, we import that now. Now when we take a look at the profiler, so we're going to start profiling, we'll increment the count once, and so we see all the cubed values have been updated. We'll reset cubed2, so then that's now 0, and we'll stop our profiler there. we take a look, we'll see on the first press of increment count, both components updated, and that's because obviously both needed to change since the cubed values had changed. But we come over here and we see that the count component memo did not change even when the cubed 2 value was reset. However, the unmemo version did change, and that's because in React, when a parent needs to re-render, all its children are re-rendered. However, the count memo version did not re-render because since it's memoized, we can cache its values and it does not need to re-render, and so therefore we've improved the efficiency of our app. Now we're going to try something different. We're going to add the squared value to the memo component only, and so we can do that like this, and we'll just add our imports memo, useState, and useEffect. And so now we've got a function that will be passed to our props. So calc squared, and that will return a number. So we see, just to explain this component, break it down a bit, we've got our squared value here, which is just a useState, and that's just empty at the start. We then have a useEffect. At any time that the count is changed, we are going to calculate the squared value from the put function that's been passed in, and then set our squared value to that. In app, we then define our calc squared function, which will be passed to our count component here in order to help it to calculate the square value. So we'll just pass that prop. The next step now will be to open that in our browser. We can test this again in our browser. We'll start profiling. We increment the count twice. We'll reset cubes 2, and that's not affected anything in here. And as we check the profiler, that should be the same. That component memo hasn't changed. So we see that it changed the first 2 times because of the update. However, we see that it also changed when we reset the value. So why has that been? Because it should not have reset. It should not have changed if we've reset Q2, because before it was memo. And the reason for that is when we come back to our code, you'll see calc squared. Every time that the parent is rebuilt, calc squared is also rebuilt. The question is now, how do we fix that? And it's pretty simple. We replace this with a use callback version of the function, and use callback, essentially what that does is it makes sure that the function is not reconstructed, remade again every time that the parent is re-rendered if it does not need to, because essentially here we've got a function that's never going to change, and that means that count component memo will never change. Since the function it's being passed is not being changed either, all we need to do is just import use callback from React. We can now go ahead and check this in our browser. So we can start profiling. We will increment the count twice. We'll reset cubed 2, and we can stop profiling there. We see now that if we scroll through, the memo components were both updated because the items were cubed. But when we get to the end, we see did not render. That's because there was no need for it to re-render since none of the values were changed, and neither was the squared function. And so that's what we want, and so we've essentially improved our efficiency now because the component did not re-render because it did not need to. These callbacks are effective ways to manage the change of states and also the re-rendering of components accordingly. However, there are some more techniques that we can use. One of these is lifting state up, and so what essentially it means is to move state to the closest common ancestor, so it's not passing props through many levels. So essentially move as much of your state as close together, so that way you're not splitting it into many components which all need to be re-rendered. The next one is to split state, and that means to divide state into smaller manageable pieces. So that means we put the state only in the components it needs to be and not in any components that don't need it. That way they don't re-render when the state changes. And to co-locate state also means to keep the state as close to where it's needed. That way those components are not re-rendered. Another one is avoiding inline functions. So going back to our use callback example, if we had defined that function as an inline function, then every time that the component was re-rendered, because the count component needs to be re-rendered, count component memo would also be re-rendered as well, since it would have to create a new instance of the function every time. The final one is lazy loading, and so this is just a technique in web development where you do not load all your components until you absolutely need them, and so this reduces the initial load time, and that way you can save how much it takes to load up your app and increase the efficiency. I hope you enjoyed this video. If you found it useful, consider liking and following. Thanks for watching, and I'll see you next time.